the next true or false question to Dr. Ramos and see if our connection catches up here. We're at the facility design and footprint portion of the conversation, Dr. Ramos, and this is the true or false statement I'd like you to respond to. Fed batch environments result in higher cost of goods per gram due to larger facility footprints, more storage tanks, higher energy and resource consumption, and lower resin utilization. Dr. Ramos, true or false? I'm not sure that we're getting through. David, would you like to take that one in the meantime?
All right, yes. I would, my answer is it's true for many scenarios. For instance, and I can name names because it's published. Paul Life Science, they did a case study. Now Cytiva, they achieved a 95% reduction in resin volume and 44% reduction in buffer consumption. Amgen also in Singapore, they achieved a cost saving of 60% or more per gram of protein in their continuous facility. UCL with Susan Ferry, they did an analysis, and they in their study, what they concluded is that especially between 100 and 500 kilograms production, you have a significant saving of about 30%. And as you go beyond that, you still have a saving, but it's lower. It's about 10% of savings. And that's also what I recently heard talking to another CDMO in Germany. They said that they are able to save about 10% in raw material costs going continuous in the downstream.
Yeah. Let's address another one of the audience questions. This one comes in from Zhao. What about continuous processing for precision fermentation? David, do you have any thoughts on that?
I have just some general thoughts. I don't have a definite answer. I would say it really depends on what are the gains. I mean, how much you can save. I have not any numbers. I have not, and I'm not familiar of many case studies telling these numbers. But I would say I would sit down and look at what are the numbers for precision fermentation, because in general the runs are much shorter than what we see in mammalian. Is it worthwhile? Is the higher, I'd say, PAT requirement worthwhile? I'm not sure. I really don't know.
Yeah. You mentioned just earlier in the response before that, you mentioned a CDMO, I believe, that achieved 10% reductions in cost of goods. So I want to ask a question about CMOs, another true or false question. True or false, most contract manufacturing organizations are equipped for batch processes, so can't support continuous lines and aren't incentivized to disrupt the profitability of proven batch processes. True or false?
Maybe if you can hear me.
We can hear you, Irina.
Camera, I'm so sorry. I'll turn off my camera because at least I can get the sound through. I can see you both. Maybe I can add something about the CMOs. And my experience has not been at the CMO, but relying on CMOs. It's actually advantageous for CMOs to start betting on have a version, it could be an hybrid process for readiness to absorb some of these continuous manufacturing processes, including on the early stage, right? You don't have to think commercial immediately. So number one thing is they might not be ready now, Matt, but they should think about maybe starting with a perfusion, and then they could batch at the purification. Maybe they could even do perfusion and the capture and batch everything else, and really offer to their customers sort of an option on their catalog without needing a large facility or a larger suite in an already existing facility. And that will bring versatility adaptability to what's to come next. And don't forget that a lot of these customers that found in their R&D small scale labs the productivity that they absolutely need to move from fed batch to a continuous upstream process that enable a business case for the fully continuous process end to end, but they do not have their own internal facilities to scale that up. So when you think about as a CMO, you're just providing that not to one customer, but to a variety of others that just had that business case trigger to move ahead. And once that clinical stage is successful, then you can start thinking as well, how would that look like as commercial? And maybe commercial is not much bigger, or it is, depends on your, of course, product and assets and forecast.
Right.
Yes.
Dr. Bruehlmann, I know you're thankful that Irina was able to connect and give you a breather there, but I'm sure you've got some reflections on her response to that question.
Yes, absolutely. I would just to add on, because I agree with you, Irina, and what I'm seeing is that largely today, many CDMOs still offer fed batch, but there is definitely a shift towards continuous. There's some prime example like just Evotech or Wuxi and some others. They are now offering a completely end-to-end continuous process. But what I also heard is talking to a smaller German CDMO, and they said that customers are not asking for continuous manufacturing. And what they're focusing on is mostly of small and mid-sized companies where they still see a high demand for fed batch, which probably makes sense because it's simpler and they don't want to invest heavily in all the PAT and digital twin requirements and so on. But definitely there is a shift towards more continuous, and I think the bigger pharma players have this mindset already, and they ask the bigger CDMOs to shift towards continuous processing.
Yeah, that's right.
Very good.
It goes back to your portfolio and your assets, right? Yeah.
Yes.
Let's take, I want to get to our second polling question, but before we do, let's just take a couple of these audience questions. Antonio is curious about the differences in risk management strategies between fed batch and continuous processing. Dr. Ramos, do you have any thoughts on the differentiation in the risk management approach between the two approaches?
Yes. And I would separate the answer from upstream to downstream. The concerns when you focus on the upstream bioreactor and you often have your continuous harvest coupled with it through an ATF or a TFF, you need to look at how do I control my process? Do I have the appropriate indicators or PAT tools? Some of them are very much the same from fed batch. Others might be Raman, for example, where a lot of colleagues want that very quick decision-making from a sensor that might give you more than just the titer or the glucose consumption. So think about now you have a bioreactor coupled with a harvest where your cells need to be kept happy and often high densities. And then you think about how much the duration of my run. Right? Is a couple of weeks, is a month, is it more? And then you have to think, how am I going to control and the process, moving it integrated with downstream? So now the process parameters that go into a batch process are a lot simpler, and they are the same that you're going to transfer to a continuous process. But in a continuous process, you have to add a few more. You have to consider residence time. You have to consider the risks of contamination and what kind of decision making you have to have accordingly to either obvious result, like an observation of contamination, and also where that contamination is happening. And how do you incorporate that into a SOP or into operational that needs to happen on the fly with your team on the floor? While in a batch, you have the advantage of isolating all the unit operations and reprocess if that's the case, or even decide to throw away the batch or part of the batch if, for example, a chromatography cycle goes wrong. So you have to consider unit operations first individually, and then you have to think about what are the inherent risks from a unit operation precursor to the following one, and how can you mitigate that risk.
Thank you, Irina. Anything to add there, David?
No, I fully agree. I think it was a very complete answer. Thank you.
Very good. All right, one more audience question from Adam. A little bit of a lengthy one here. As someone fairly new to these fields, is continuous processing equally beneficial across both extracellular products and intracellular products? And in general, with the great improvements in yield from continuous processing, would you say that downstream processes have in general been able to withstand the increased yields? David, you want to start with that one?
Yes. So the first part of your question, I think, goes back to a previous question we talked about precision fermentation. I would say I would give the same answer because it really, well, obviously it's difficult to give you a precise answer not knowing what the product is. But again, it depends on what is the benefit of the increased complexity, because continuous processing is more complex. It's just more complex to run your especially the upstream, and then if you have a multi-column or a fully continuous downstream, it's very complex also in the automation. And then the added PAT and layer and digital twin layer. So again, it really comes down to that, whether it makes sense or not. For the second question, now with the increased continuous capabilities, for a long time, actually, the downstream was the bottleneck, but not today anymore. So we definitely are able to treat much higher yields now with more sophisticated downstream platforms.
Thank you, David. Anything to add, Irina?
Just the opportunity we have with continuous manufacturing, that early on in process development, you can fully utilize your resins, for example, by cycling them. They come now with a much higher capacities. You can save money on the clinical stages that before it was not a goal for the companies. And you, of course, you would only do the cost of goods manufactured calculations for the commercial forecast. So that's a good opportunity, giving the better tools to optimize downstream process as well.